Here we have a division problem, and it's asking us to give the quotient and the remainder. The quotient, that's what you typically think of as the answer, the thing at the top of that bracket, when you set up a division problem like this, 271 divided by 7. The thing up here we call the quotient, and the remainder is actually part of the answer too, but it's kind of what's left over at the end that you can't actually divide by 7. So I'll show you how that works in this one. The first step is to look at the first number here under the bracket and say, can I divide that by 7? And 2 is smaller than 7, so that's not going to work. So then we go to the next digit over, we take both those together, we have 27. So can we divide 27 by 7? And yeah, 27 is definitely bigger than 7, so some amount of 7s fit in there. What is 27 divided by 7? And I think for some people, this is the hardest part. What's that number we're going to put on the top here? And one approach to figuring that out is to start listing the multiples of 7. So I'm going to start with 2. 2 times 7, that's 14. 3 times 7, that's 21. Oh, we're getting pretty close there now, so that might be our candidate. Let's go one more. 4 times 7, that's 28. Aha, and that's too big. So when you find the one that's too big, you just go back one, and it's this 3. So if we divide 27 by 3, we're going to have, divide 27 by 7, we're going to have 3 and something left over. So we put the 3 up here. Now we do our multiplication. 3 times 7 is 21, and then we do our subtraction. So 27 minus 21 is 6. And then we bring down our 1. So now we've got 61 here, and that's an even bigger number, maybe more difficult to figure out how many 7s go into 61. What would 61 divided by 7 be? So knowing what number to put up here, I think I'm going to go backwards from 10 with our multiples of 7. So 7 times 10 I know is 70, and that's pretty close to 61 already. If I go one less than that, 7 times 9, let's see, if I don't know that off the top of my head, it'd be 7 less than 70, so that would be 63. That's still too big, so it looks like I have to do one more. 7 times 8, and let's see, we'd take away the 3 to get to 60, and then 4 more, we'd get to 56. Okay, so we want 7 times 8. So we'll put the 8 up here, and now when we do our multiplication step, we've got that 8 times 7. So that is 56. And we need to subtract. So 1 minus 6 can't do that. Got to borrow. So we'll make that a 5. And this is now 11. So 11 minus 6 is 5. And 5 minus 5 is 0. So we just end up with 5 here. And you'll notice 5 is smaller than 7. So you can't divide that anymore. So our quotient is 38. And our remainder is actually 5. And sometimes people will write R5 like that. All right, that was a lot of steps. Let's try one more to see if we can get this more automatic. We've got an even bigger one. And actually, we're going to do this in that same traditional way, and then I'm going to show you a shortcut and see if it's something that you might want to use. But let's set this up. So we've got, I'm going to make our bracket here. We've got 2 on the outside and 1, 7, 3, 1. So let's see, 1 we can't divide by 2, but 17 we could. And let's see, I know pretty quickly that 2 times 8 is 16. So that seems like the right candidate. 17 is just one more than that. So if I put an 8 up here, I would get 2 times 8, that's 16. Then we'll subtract, and we get a 1 here, and we'll bring down the 3. So now I've got 13, and it's kind of easy with the 2's because I know my 2 multiplication tables pretty well. 2 times 6 is 12, so I think that's the one to use there. So I'll put a 6 up here. 6 times 2 is 12, so that goes here. And then we'll subtract again. I get 1 again, and then we'll bring down this 1. And now I think it's going to be 2 times 5 is 10. Yeah, so we'll put a 5 up here, and 5 times 2 equals 10. So we put that down there, and then we subtract and we get 1. And we can't divide 1 by 2. So this is going to be our remainder, and this is going to be our quotient right there. So 1,731 divided by 2 is 865, remainder 1. That's typically how you'd say that. So a lot of steps to get there. If you're confused at all by this part, the reason I'm choosing these is because I want to find the closest multiple to whatever number we're looking for without going over. So for example, 2 times 6 brings us to 12. That's the closest to 13 without going over. So that's how I made those decisions. But this problem, and most problems when you're dividing by 2, are probably easier. There's an easier way to do than this. So let's think of 1,731 as 1,000 plus 700 plus 30 plus 1. And let's try to divide all those pieces by 2. 1,000 divided by 2, I know off the top of my head it's 500. I also know that for 700, it's 350. And if you didn't know that, you might think, well, let's see, 800 is divided by 2 is 400, and 600 divided by 2 is 300. So 700's got to be right in the middle of that, between 300 and 400, and that's how I got to 350. 30 divided by 2 is 15, and then we've got 1. So I can just add all these up together. Let's see, 500 plus 350 would be 850, and plus 15 would be 865. That's our quotient. I leave this part off because you can't actually divide that by 2. I shouldn't have put that plus there. This 1 was just left. Let's erase that from there. So this is 865 and remainder 1. So when you get a big number and you're trying to divide it by 2, you might want to try this method. It's totally up to you. So that's a little bit of work with some more long division.